Hi all, this is the first part of the video lectures on second semester MSc Computer Science, subject Modern Operating Systems. In this video, we will be covering the introduction to operating systems. The contents in the introduction to operating system video lecture is what is an operating system. That is, first we will discuss the definition of an operating system. Then we will discuss different types of operating system. That is, mainframe systems, desktop systems, multiprocessor systems, distributed systems, clustered systems, real-time systems, and handheld systems. We will discuss what is an operating system. An operating system is a program that manages the computer hardware. It also provides a basis for application programs and acts as an intermediary between a user of a computer and the computer hardware. The major goals of operating systems are execute user programs and make solving user problems easier. That is, it will make the computer system more convenient to use. For example, while calling a printf statement, the OS will load the function into the memory. We need not bother about the code or linking or loading. Library modules also be handled in the same way. So the user can concentrate on his domain without bothering about the system goals. The next responsibility of an OS is the management or resource management of computer hardware present in the system. In C programming, we will usually do an malloc function. In malloc, we will be requesting memory dynamically. So, how the dynamic allocation is done? That is actually done by the operating system. When malloc call is executed, the OS will provide us the requested size of memory. This is an example of resource allocation and management. So, OS is helping us to efficiently manage the computer hardware. This is the system's perspective of operating system. The popular operating systems are Windows, Microsoft, Mac OS from Apple, Android. Android is a mobile application operating system. Then Linux. Linux is a free uh, open source software. An amazing aspect of operating system is how varied they are in accomplishing tasks. Mainframe operating systems are designed primarily to optimize utilization of hardware. Personal computer operating systems support complex games, business applications, etc. And handheld computer systems are designed to provide an environment in which a user can easily interface with the computer to execute programs. Thus, some operating systems are designed to be convenient, others to be efficient, and others some combination of the two. We begin our discussion by looking at the operating system role in the overall computer system. System considered as a collection of four components, that is hardware, application programs, operating system, and users of the system. Hardware provides the basic computing resources present in the system. Examples are CPU, memory, IO devices. These are contributing the hardware present in the system, basic resources in the system. So, the major role of the operating system is to manage the underlying hardware and fairly distribute the resources among the application programs or the end users. Next, application programs. Application programs define the ways in which the system resources are used to solve the computing problems of the users. That is, as end users, we are relying on the computer for executing problems or to find out solutions for our problems. That is, we will use compilers, we will use database systems, we will perform video games, we will perform business programs. Okay, for all these purposes, we are daily depending on computer. So there will be a lot of application programs, and many users will be logging into the system for different types of services provided by the server. uh, Operating system. Operating system, as shown in figure, it is above the hardware. That is, just above the hardware, there is we are presenting the operating system, and the function of this operating system is to control and coordinate the use of the hardware among the various application programs for the various users. So it will be between the hardware and the user. This is operating system is the intermediary between the user and the hardware, and above this operating system application programs are being run. Okay, and last we will have perspective of operating system. It should provide an easier way to use the system, and system's perspective of an operating system is it should be a resource allocator. Computer system has many resources that may be required to solve a problem, like CPU time, memory space, file storage space is needed, IO devices, and so on. So operating system acts as the manager of these resources. There will be numerous and possibly conflicting requests for resources. So at that time, the OS must decide how to allocate them to specific programs and users, so that it can operate the computer system efficiently and fairly. It is specially concerned with the operation and control of IO devices. Actually, operating system is concerned with the operation and control of IO devices too. There will be conflicting requests for IO devices as well as CPU. So, operating system must decide who should be given the priority. Okay, whenever one process is going for IO operation, the other process should be given to the processor for execution. Okay, this management is done by the operating system. Abstract view of system components are shown. In the lowest layer, we can see the computer hardware. Computer hardware is at the bottom of our computer system. Is managed by the operating system. So operating system is shown just above the computer hardware, and above the operating system we have our different system and application programs. There will be compilers, assemblers, text editors, database systems, web browsers will be there. Okay, a lot of system and application programs will be running at the same moment, and the operating system is managing all these application programs and the system programs, and it will fairly allocate the system resources, that is computer hardware, to the end users or the requesting application programs. Okay, here user 1 is requesting compiler, user 2 is running an assembler, user 3 may be using a text editor, and user n is using a database system. So there will be conflicting requests, there will be a lot of requests at the same time from different users. So there is a manager, and the manager is the operating system. So this is the abstract view of system components. Now we will discuss operating system definitions. Operating system is a resource allocator, and it manages and allocates the resources present in the system. System is it acts as a control program, that is it controls the execution of user programs and operations of IO devices. Now we will discuss the different types of operating system, and the first one that we are going to discuss is mainframe systems. Systems were the first computers used to tackle many commercial and scientific applications. Initially considered as a simple batch system. So in a simple batch system, what happens is the computer runs one and only one application. Then developed time shared systems. Time shared systems allowed a user interaction with the computer system. So initially we will discuss batch systems. In batch system, what is done is the operators batched together jobs with similar needs and ran them through the computer as a group. Thus, programmers would leave their programs with the operator. The operator would sort programs into batches with similar requirements, and as a computer became available, they would run each batch. The output from each batch would be sent back to the appropriate program. Okay. In this execution environment, what happens is the CPU is often idle. Why? Because we have the first session of operating system. In initial memory locations, we will be providing the operating system, and the rest of the space is reserved for user programs and data. In this execution environment, what is happening is the speeds of mechanical I/O devices are intrinsically slower as compared to those of electronic devices. Okay, we know that even a slow CPU works in the microsecond range, so it can execute thousands of instructions per second. But at that time, card readers were used. That is, in batch systems, card readers were used that might read only 1200 cards per minute, that is only 20 cards per second. So we can notice a huge difference in speed between the CPU and its IO devices. So when a batch is going for an IO operation, what happens is at that moment the CPU will sit idle. So this is a problem with the batch system. We got a disk technology. In disk technology, what happened is disk technology allowed the operating system to keep all jobs on a disk rather than in serial card reader. Okay, we can keep the jobs on disk. So we will get access to different types of jobs at the same time. So there is a job scheduling requirement on behalf of operating system. What happens is it increases the responsibility of the operating system, and it should perform job scheduling, that is to select most priority jobs from the job pool, and it should be occupied by the main memory. That is, these jobs should be, that is selected jobs should be placed in the main memory. When the execution get completed, that jobs should be swapped out from the main memory to the job pool, and the next prioritized programs or prioritized tasks should be allotted to the main memory. This is the responsibility of the operating system, or this is job scheduling. And so in this example, we can see that in first locations operating system were loaded. Several jobs are kept in main memory at the same time, and the CPU is multiplexed among these jobs. That is, when job 1 is being executed, it will be need of an input from the external, from the user. So at that time it will go for the in IO operation. It will go to the IO go to perform the IO operation. At that moment, job 2 will be occupied by the processor, and it will proceed with its execution. When job 2 is going for an IO operation, what will happen? Job 3 will be allotted to the processor. When job 3 is going for an operation, job 4 will be allotted for the execution. Now we will discuss operating system features needed for multiprogramming. First is IO routine supplied by the system. That is, the input output operations are also supported by the same operating system. Then comes memory management. Multiprogramming is the first instance where the operating system must make decisions for the users. In multiprogrammed operating system, all jobs that enter the system are kept in the job pool. This pool consists of all processes residing on disk awaiting allocation of main memory. If several jobs are ready to be brought into memory, and if there is not enough room for all of them, then the system must choose among them. Making this decision is job scheduling. When the operating system selects a job from the job pool, it loads that job into memory for execution. Having several programs in memory at the same time requires some form of memory management. Finally, several jobs are ready to be run at the same time. The system must choose among them. Making this decision is CPU scheduling. Multiple jobs running concurrently require that their ability to affect one another be limited in all phases of the operating system, including process scheduling, disk storage, and memory management. Then there should be multiple requests from multiple users and multiple tasks for IO devices. So allocation of devices should also be managed, or that decision must be made in a logical way, that these devices should be allotted to all tasks in a fairly way. Now we will discuss time sharing system. Time sharing or multitasking is a logical extension of multiprogramming. The CPU executes multiple jobs by switching among them, but the switches occur so frequently that the users can interact with each program while it is running. An interactive computer system provides direct communication between the user and the system. The user gives instructions to the operating system or to a program directly using a keyboard or a mouse and waits for immediate results. Accordingly, the response time should be short, typically within 1 second. A time-shared operating system allows many users to share the computer simultaneously. Since each action or command in a time-shared system tends to be short, only a little CPU time is needed for each user. As the system switches rapidly from one user to the next, each user is given the impression that the entire computer system is dedicated to her use, even though it is being shared among many users. A time-shared operating system uses CPU scheduling and multiprogramming to provide each user with a small portion of time-shared computer. Each user has at least one separate program in memory. A program loaded into memory and executing is commonly referred to as a process. When a process executes, it typically executes for only a short time before it either finishes or needs to perform I/O. I/O may be interactive, that is, input is to a display for the user and input is from a user keyboard, mouse, or other device. Since interactive I/O typically runs at people's speed, it may take a long time to complete. Input, for example, may be bounded by the user's typical speed, typing speed. 7 characters per second is fast for people, but it is incredibly slow for computers. Rather than let the CPU sit idle when this interactive input takes place, the operating system will rapidly switch the CPU to program some of other users. Desktop systems. Personal computers appeared in the 1970s. During their first decade, the CPUs in PCs lacked the features needed to protect an operating system from user programs. PC operating systems were at that time it was neither multi-user or multitasking. However, the goals of the operating systems have changed with time. Instead of maximizing CPU and peripheral utilization, the systems opt for maximizing user convenience and responsiveness. These systems include PCs running Microsoft Windows and the Apple Macintosh. Operating system for these computers have benefited in several ways from the development of operating systems for mainframes. Microcomputers were immediately able to adopt some of the technology developed for larger operating systems. On the other hand, the hardware costs for microcomputers are sufficiently low that individuals have use of the computer and CPU utilization is no longer a prime concern. However, these computers are now often tied into other computers over local area networks or other internet connections. When other computers and other users can access the files on a PC, file protection again becomes a necessary feature of the operating system. Multiprocessor systems are systems with more than one CPU in close communication. They are also known as tightly coupled systems. In tightly coupled systems, processors share memory and clock. Communication usually takes place through the shared memory. There is no need for separate storage devices or separate I/O devices. That is not needed. So, such systems are known as tightly coupled systems or parallel systems. Advantages of parallel systems are it is providing increased throughput, but then economy of scale is high. That is, in multiprocessor systems, they can save more money than multiple single processor systems because they can share peripherals, mass storage, and power supplies. If several programs operate on the same set of data, it is cheaper to store those data on a disk and have all the processors share them than to have many computers with a local disk and many copies of the data. Then, third term is increased reliability. In increased reliability, we have two terms that should be noted, that is graceful degradation and fault tolerant system. Graceful degradation, imagine that we are running in 10 machines. 10 machines are working together as a distributed system, and if one of the system fails, the work of that system will be taken care of the remaining 9 machines. So the entire system runs only 10% slower rather than failing altogether. This ability to continue provide service proportional to the level of surviving hardware is called graceful degradation, and such systems are known as the systems designed for graceful degradation is known as fault tolerant system. The most common multiprocessor systems are now using symmetric multiprocessing. In symmetric multiprocessing, each processor run an identical copy of the operating system, and these copies communicate with one another as needed. SMB means that all processors are peers, no master slave relationship exists between processors. Uh, each processor concurrently runs a copy of the operating system. See the figure here, we can see that typical SMB architecture is shown in this figure. Okay, then we have asymmetric multiprocessing. In asymmetric multiprocessing, each processor is assigned a specific task. A master processor controls the system. There is a master slave relationship. So, a master processor controls the system. The other processors either look to the master for instruction or have predefined tasks. This scheme defines a master slave relationship. The master processor schedules and allocates work to slave processors. It is more common in extremely large systems. Now we will discuss distributed systems. In distributed system, it distributes the computation among several physical processes. They are also known as loosely coupled system. In loosely coupled system, in the previous slide we have discussed the tightly coupled system. So you are familiar with that. Now we will discuss loosely coupled system. In loosely coupled system, each processor has its own local memory. Processors communicate with one another through various communication lines such as high speed buses or telephone lines. So communication should be possible with the help of some network infrastructure. That is the main requirement in loosely coupled system. Distributed systems depend on networking for their functionality. By being able to communicate, distributed systems are able to share computational tasks and provide a rich set of features to users. And different types of protocols used. Here, the most common network protocol used is TCP/IP. Most operating systems support TCP/IP, including Windows and Unix operating system. To an operating system, a network protocol simply needs an interface device like a network adapter with a device driver to manage it and a software package data in the communications protocol to send it and to unpackage it to receive it. Okay, usually LAN, WAN communication are possible. Then advantages of distributed systems are it support resource sharing, and then it support load sharing. If one of the system fails, rest of the systems will take care of the failed system, and the user will not be knowing about the crash. Then it is a reliable system. The service will be uninterrupted. Then communication. The whole task is achieved by communication among nodes. So this is distributed systems. We will discuss clustered systems. Clustered systems are also similar to parallel system, but it is different thing. Okay, that is they are composed of two or more individual systems coupled together as the same way in distributed system. But the difference is that the clustered computers share storage and are closely linked via a LAN network. And the main aim of clustered system is to provide high availability. Okay, that is, if one of the system fails, there must be the other system to take care of that the failed system. A layer of cluster software runs on the cluster nodes. Each node can monitor one or more of the others over the LAN. If the monitored machine fails, the monitoring machine can take care of ownership of its storage and restart the applications that were running on the failed machine. The failed machine can remain down, but the users and clients of the application would only see a brief interruption of service. There are two types of clustering, that is asymmetric clustering and symmetric clustering. In asymmetric clustering, one machine is in hot standby mode while the other is running the applications. The hot standby host does nothing but monitor the active server. If that server fails, the hot standby host becomes the active server. In symmetric mode, two or more hosts are running applications and they are monitoring each other. This mode is obviously more efficient as it uses all of the available hardware. It does require that more than one application be available to run. So this is clustered systems. We will discuss real-time systems. It is a special purpose operating system. A real-time system is used when rigid time requirements have been placed on the operation of a processor or the flow of data. Thus, it is often used as a control device in a dedicated applications. Here, sensors bring data to the computer. Control devices in dedicated applications such as controlling scientific experiments, medical imaging systems, industrial control systems, and some display systems. There is a well defined fixed time constraints, and these real time systems can be hard real time systems or soft real time systems. Okay, time constraint is the major concern in real time systems. Okay, real time systems two varieties, as we said, hard real time system and soft real time system. In hard real time system, um, the system guarantees that critical tasks be completed on time. And soft real time system, in hard real time system, the system guarantees that critical tasks be completed on time. uh, all delays in system should be bounded from the retrieval of stored data to the time that it takes the operating system to finish any request made of it. That is, secondary storage is limited or absent in hard real-time system. Data is stored in short-time memory or read-only memory. There will be conflicts with the real-time sharing systems not supported by general-purpose operating systems. Soft real-time systems is less restrictive type of real-time system where a critical real-time task gets priority over other tasks and retains that priority until it completes. As in hard real-time systems, the operating system kernel delays need to be bounded. A real-time task cannot be kept waiting indefinitely for the kernel to run it. Soft real-time systems is an achievable goal that can be mixed with other types of systems. Um, they have more limited utility than hard real-time systems. Then there is a lack of deadline support. They are risky to use for industrial control and robotics. They are useful in several areas like multimedia, virtual reality, and advanced scientific projects such as undersea exploration and planetary rovers. These systems need advanced operating system features that cannot be supported by hard real-time systems. Because of the expanded use of soft real-time system functionality, it is finding its way into most current operating systems, including major versions of Unix. Now we will discuss handheld systems. Handheld systems include personal digital assistants, cellular phones, palm tops, etc. It comes with connectivity to a network such as the internet. Developers of handheld systems and applications face many challenges. There are different types of issues they have to consider while designing handheld devices or operating system for a handheld device. For example, a PDA is typically about 5 inches in height and 3 inches in width, and it weighs less than 1/2 pound. Due to this limited size, most handheld devices have a small amount of memory, include slow processors, and feature small display screens. So these are the issues that we have to consider. Operating system and applications must manage memory efficiently. This includes returning all allocated memory back to the memory manager once the memory is no longer being used. Second issue of concern to developers of handheld devices is the speed of the processor used in the device. Processors for most handheld devices often run at a fraction of the speed of processor in a PC. Faster processors require more power. To include a faster processor in a handheld device would require a larger battery that would have to be replaced more frequently. To increase the size of most handheld devices, smaller, slower processors which consume less power are typically used. Therefore, the operating system and applications must be designed not to tax the processor. The next issue confronting program designers for handheld devices is the small display screens typically available. So here we will use web clipping. Web clipping is the technique for displaying the content in web pages where only a small subset of a web page is delivered and displayed on the handheld device. Now we will come to the conclusion of this lecture. We have discussed the definition of operating system. We have defined the roles of operating system, and different types of operating systems were discussed, like mainframe systems, processor systems, handheld systems, real-time systems, etc. were discussed in detail. So thank you.